Welcome to Tutoring Thursday, where we answer your college and university level subject questions. If you would like your question to be featured on our next week's session, please submit your question to questions@academicgurusinc.com. Okay, so today we are working with a physics question. I know a lot of people don't like physics, but physics doesn't really have to be a scary subject. I think the key is always to break it down into its components, try to understand it at its elementary level, and then analyze the question from there. So that is exactly what we'll try to do here. So let's read that question. It reads, two balls of equal mass are approaching the coordinate region. While one is moving downward along the y-axis at 4 meters per second, the other is moving to the right along the negative x-axis at 6 meters per second, and the two balls collide. After the collision, one of the two balls moves to the right along the positive x-axis at 2.4 meters per second. What is the scalar x and y velocity component of the second ball? Okay, so there are three key points to recognize here, and one of them being that this is a two-dimensional collision. The balls are strictly moving in either the y-axis direction or x-axis. The second point to recognize is that the question surrounds only two objects, two balls, we can call it ball A and ball B. There are no external factors at play here, so therefore momentum is conserved. The total momentum is conserved because it is a closed system. With a question like this, it's always a good idea to draw out the scenario. So here I've drawn out the coordinates, and if we consider this to be the y-axis and this the x-axis, the question says that the two balls are moving towards the region, so in this area here. That is the point at which they collide. If we want to call the first ball ball A, the question says that ball A is moving in the right direction along the negative x-axis at 6 meters per second. So if we draw that out, the question also reads that we can call this ball B is moving downwards along the y-axis. We can assume here that that is along the positive y-axis since they are colliding. So it is moving downwards at 4 meters per second. So again, we can assume that the point of collision is at the region right here. Now with a change of color, I'm going to show what happens after the collision. The question reads that after the collision, one of the two balls moves to the right along the positive x-axis at 2.40 meters per second. The question doesn't indicate the direction of the second ball, therefore we can assume that it is not moving. Now that we have a visual understanding of what is going on in the question, we can move on to the formula. How do we define momentum? Momentum is simply mass times velocity. Now to simplify things, we'll simply use the variables P for momentum equals m for mass times v for velocity. And P before will specify momentum before, while PA will specify momentum after. So now we'll be focusing on momentum along the x-axis. Given that momentum is defined by mass times velocity for the x direction, we have P before in the x direction equals P after in the x direction. So momentum is conserved, therefore momentum prior to the collision is equal to momentum after the collision. So we will redefine this as the mass of ball A multiplied by its velocity, which is 6 meters per second, plus the mass of the second ball times its velocity, which is just 0, is equal to the mass after the collision for the second ball, which is 2.4, plus the mass of the second ball after the collision times its velocity in the x direction after the collision. We don't know what that velocity is. That is what we're trying to figure out. We can now just cancel out the m times 0 because that's just simply 0. And we can rewrite the equation as m for mass times 6 equals m times 2.4 plus mvx of the second ball. Now the goal here is to isolate vx, the velocity of the second ball, which is unknown. Therefore, we want to try and get rid of the 2.4 times x, and we do that by subtracting it from this side and subtracting it from that side as well. This leaves us simply with m 3.6, which equals m vx. We can cancel out the masses. This leaves us with Vx equals 3.6 meters per second. We'll repeat the same thing for the y coordinate now. And so we have P, B, y must equal P, A, y. So momentum in the y direction before should equal the momentum in the y direction afterwards. So we'll take the mass of the first ball and its velocity in the y direction, which is simply 0, plus the mass of the second ball times -4 meters per second for the velocity of the second ball. Now, a side note here, I'm using negative, and you may ask, well, the original question says that it's moving 4 meters per second. However, bear in mind, this is the tricky part, it's moving downwards, and therefore the negative sign besides the 4 reflects that it is moving in a downwards direction. So be very careful here. Okay, so after the collision, we have the mass of the first ball with a 0 velocity plus the mass of the second ball with the velocity which we're trying to determine in the y direction. So again here, this just becomes 0, and we can cancel out all the m's, and what that leaves us with is -4 is equal to Vy. Therefore, the velocity in the x direction is 3.6 meters per second, and the velocity in the y direction is -4 meters per second. Do you have a question you would like our gurus to solve? Your question could be featured on next week's Tutoring Thursday session by submitting it to questions@academicgurusinc.com. If you enjoyed watching this video, let us know by giving us a thumbs up, subscribe to our Tutoring Thursday channel, or leave us a comment. Let us know how we're doing. Until next week's Tutoring Thursday, happy studying.